Hey folks, Mr. Bullock here, and here are some sample questions for the upcoming AP test you're going to take for statistics. Let's go ahead and begin. It's going to take a bit. So these are the first 20. Which is true about correlation? Correlation makes no distinction between explanatory and response variables. Well, that's true. Correlation requires that both variables be quantitative. Well, that's true also. Correlation measures strength only of a linear relationship between two variables, true. And correlation is always a number between -1 and +1. So it's choice E. All of those babies are true, okay? All right. A survey records many variables of interest to the researchers conducting the survey. So which of the following variables, that should be plural, from a survey conducted by the United States Postal Service is categorical? Okay, categorical is things that don't deal with numbers, you guys. All the ones that we can average, like I can average this one, and this one, these are quantitative. So it's choice A is the only categorical one right there, okay? All right. Which of the I have to go fast, you guys. I got 20 of these babies. So which of the following are true statements? Stem plots are both useful for quantitative and categorical. No, not categorical. Stem plots are equally useful for small and large data, not large data. They're too cumbersome. Stem plots can show symmetry, gaps, clusters, and other outliers. That one's true, so it's choice C. Okay, let's see. So under standard normal curve, the area bounded by the x and y axes and the line x equals 3 is 0.4987. And the standard normal distribution, well, that means it's symmetrical. Standard normal means it's symmetrical. So what percent of the data is between -3 and +3? Well, if this is between 0 and 3, it should be the same on the left. So if I just double that, that'll get me choice D right there, okay? All right. Let's see. A reporter wishes to portray baseball players as overpaid. Which measure of center should she report as the average salary of the major league players? Okay, well, I do the mean, you guys. The mean would tell everybody that they are totally overpaid. If we did something like the median, it doesn't do very well. And the mode, that just tells me which one's the most, where there's more poor people than there are rich people. And the median just tells me the middle number. Well, if you ranked everybody, so if you did the average, that would show you that it would pull it quite to the right. It would be skewed to the right. Okay, so the mean salary of all female workers is 41,000. The mean salary of all male workers is 35,000. What must be true about the mean salary of all workers? Well, since I don't know how many female workers there are and how many male workers there are, I can't really determine anything except that the average of all of them is somewhere between these two numbers right here. So it's only choice C, because there could be one female worker and 20 male workers, or vice versa. I don't know. So which would influence all those other scores. So the only thing I can say is that C is true. Okay, and if the standard deviation of a set of numbers is 0, you can conclude what? Well, think of this, you guys. Standard deviation is like how much the numbers vary from each other. Well, if they vary from each other by 0, okay, then that means all the observations have to be the same. They got to be equal to each other, okay? So I said something else about the formula there. So let's see, a set of data has a median that is much larger than the mean. Okay, remember the mean is pulled in the skewness, you guys. So if the median is larger, that means the median is to the right, which means the mean is to the left, which means it's skewed to the left. So choice B. Okay, so the mean always gets pulled towards the skewness. Okay, all right, what did I say? So, okay, so here's a stem plot right here. Okay, take a look at this. This baby is skewed to the right because it has a big long tail to the right. It has an outlier way over here. It's not symmetrical, which means it's asymmetrical, and its mean is less than 30. I would guess so, because here's 30 right here, and most of these guys are less than 30 right there. So I'm going to say all of them right there. Okay, that's a classic skewed to the right photo right there. All right, so it's E. Okay, in a stats class with 136 students, the professor records how much money each student has. So the histogram that we just talked about is the set of data collected. So the percent of students that's under $10 is closest to. Okay, so what I did is I just kind of generalized, you guys. Okay, so this looks like about 63. This looks like it went up about 43 and about 20 and so on and so on. So I added all those up to get 136, so that was correct. And then the ones that's less than $10 is this column right here. So 63 out of 136 is roughly equal to about 46%. So it says which one is it closest to it. Well, 46 is closer to 50%. I don't know what the book was saying here, so I'm getting choice C on that one. So unless you guys can say something, please email me on that. I just don't see it. Okay, so with the same histogram, the number of students that have over $30 is about, okay, let's go back to that picture right there. Over $30, okay, it's this one. 5, 6, 7, 8, 9, about 10. Okay, so it's about 10 people, choice B. All right, if the heights of 99.7 of American men are between 5 feet and 7 feet, what would be a good estimation of the standard deviation? Okay, this symbol means standard deviation, remember? The sigma symbol. Okay, well, since these are all in terms of inches, between 5 feet and 12 feet, that's 24 inches, you guys. And remember the 68, 99, or 95, 99.7 rule? It's called the Empirical Rule. Some books call it the 68, 95, 99.7 rule. It talks about 1 standard deviation, 2 standard deviations, and 3 standard deviations from the mean. So this means 3 standard deviations from the mean. Okay, so this is 3 standard deviations above the mean. This is 3 standard deviations below the mean. So that's a total of 6 standard deviations. So it spans over 24 inches. So 6 goes into 24. I'm guessing about 4 times. So each standard deviation is about 4 inches. Okay. Set of data is skewed to the right, which is true. The mean is to the right of the median. That's true. The mean is to the left of the median. Nope, the mean and the median are roughly the same. No, remember the mean gets pulled in the direction of the skewness. So the only one that's true is choice A. Okay, all right. Below are the team-by-team statistics of home runs hit through Friday, June 3rd of the 1994 baseball season. Okay, so I think baseball starts, let's see, today is March 17th, so it's going to start in like 15 days or 13 days, something like that. Okay, so we got to count them, you guys, to find the median. The median's the middle one. So I count 14 of these guys, so the median is going to be the 7th and 8th one. So 1, 2, 3, 4, 5, 6, 7, 8. So the median is between 57 and 58. So the median would be 57.8. I'm sorry, 57.5. So it's this one. So the median of home runs of the American League is exactly 57.5. Okay, the median over here, 1, 2, 3, 4, 5, 6, 7. So between 48 and 53. So if I average those, what's that? That's 5.5. So I'd add, a couple, it'd be somewhere between 48 and it'd be like 50 point something. Okay, so the answer is E on that one. So we're going to use the stem plots, and which of the following is a correct statement? The American League plot is reasonably symmetrical. Let's pull that plot back up. Okay, and think of these being turned sideways. If you can turn your head to the right 90 degrees while you're looking at this, okay, and then you're looking at this graph, this looks roughly symmetrical, kind of looks like a nice bell-shaped curve. Okay, B says the national plot is slightly skewed to the left. Yeah, I guess so. That's slightly skewed to the left just because of these two little dudes right here. The median of the American was higher than the nationals. Yeah, remember this one was the 57.5. This one was like 50 something. Okay, the 29 in the national is not an outlier. Yeah, I'd pretty much say that's not an outlier. I'll have another video on how to determine outliers, but the outlier has to be 1.5 times the IQR below the first quartile right there. So anyway, so I know it's not that. So it's all the above, so it's choice E on that one, okay? All right, a community college announces that the correlation between college entrance exams grades and the scholastic achievement was found to be negative 1.08. On the basis of this, you would tell the college that. I would tell the college to get a new statistician, because remember the correlation is somewhere between -1 and +1, and that's outside the range, so they made a mistake. Okay, so let's see. Let's see. So for children between the ages of 18 months and 29 months, there is an approximate linear relationship between heights and age. So the relationship is modeled by, so this is called the least square regression line right here. We'll have lessons on this. So is modeled by this, where y is the height and x is the age. Okay, so Joseph is 22.5 months old. That's the age. That's x. So what's his predicted height? So I'm just going to plug in 22.5 right there, and then just crank it out, and we're going to get about 50.8 would be his predicted height. So in centimeters. Okay. And then we're going to use that same use the same information to answer the following. Darren is 48.12 centimeters tall. What's his predicted age? Okay, so that is the y. Okay, so this goes in for the y. So I'm going to put it right there, and then solve for x. Okay, and if you did your math right, you get a again. Alrighty. Okay, which of the following is likely to have a mean that is smaller than the median? Okay, so it would be something that is skewed to the left. Okay, salaries of all NFL players. The salaries of NFL players is definitely skewed to the right. It's not that one. The scores of students on a very easy exam, which most get nearly a perfect score, but few do very poorly. Okay, so it's the one that's going to be skewed to the left, you guys. So it's going to be the scores of students on a very difficult exam, where most of the students get poor scores, but there's very few. That's like the rich people. There's very few rich people, but it skews it way to the right. There's lots of poor people, or there's lots of very poor scores. So this one will be skewed to the left, so it's this guy right there. Okay, and then I got a 19b, I think, yeah. Which of the function is monotonically increasing? So one that just keeps going up, up, up to the right. That's all that means, you guys. Think of this. This is a linear relationship. It's y equals negative x. It goes down like this, so that one's decreasing. Okay, this y equals negative x squared is an upside down quadratic parabola. It's a parabola that goes like this. Okay, but this one goes increasing, increasing, then it starts decreasing on this side, so it's not that one. Okay, y equals negative x cubed would look like this. It would be kind of a sort of a S-y sort of shape, kind of. It goes down like that. Not that one. It's this one right here. This one goes up through the origin, and it goes up like this. Okay, so remember that from pre-calculus? All right, so it's that one. That one's the only one that goes only up and up and up. This one here, y equals x to the fourth, that one goes like this. Okay, so it's not that one. That one decreases and then it increases. Okay. All right, what else do I have? The mean scores on the stats exams was 75 points with a standard deviation of 5 points. Gregor's z-score was -2. So you just go down 2 and that'll get you choice B. Okay, 2, so 5 points. So 5 times 5, or 5 plus 5 is 2 standard deviations below. So that gets me that one. Which of the following statements are true? Correlation regression requires there are clearly identified explanatory and response variables. Not necessarily. Scatter plots require that both variables be quantitative. That's true. Every least square regression line passes through the average of x bar, y bar, so that's the average of the x's and the average of the y's. That's true also. So I get choice C. It's numbers 2 and 3. Okay. All right. I'll have some more in another video. You guys take care.